Hello, let's look at a typical application for the quadratics. So here, application. So here is one of the classical examples for the quadratic equations, and it has to do with finding the maximum area of a garden. So here is an example. Let's say we have 1,000 foot of fence and we wish to make a rectangular garden, and the rectangular garden is going to be such that on the north side of it is going to be our house, so we don't actually need the fence. All of this is a house, and on the other three sides we will use the fence to make a rectangular garden. The question is, what's the biggest area and what are the dimensions that will make this biggest area? And that's a classical example. So this requires us to know two things. One is the area of a box, and the area of a rectangle is x times y, or length times width. But we cannot do anything with this formula because we don't know, we have to have the same variable, either all x's or all y's. And to get it to have just one variable, we're given the information that we have 1,000 foot of fence, and the fence goes around the garden, and it is the perimeter. So the perimeter is 1,000, and that also means that if we take 1x plus 2 y's for each vertical side, we should use 1,000 foot of fence, which means x plus 2y is 1,000. Now, if we solve this equation for the y, we will be able to use that y into the area formula. So let's get y by itself, which means canceling the x from both sides, minusing it from both sides, and then dividing both by 2. So dividing each number by 2, we'll get 500 minus 1/2 x. And this is what the y equals, and if that's what it equals to, we can use it for the area formula as well. So the area then becomes x times 500 minus 1/2 x, and we can multiply through by x, making 500x minus 1/2 x squared. That's a quadratic. The highest power is 2, and we usually write them in descending order. The highest power would be first, so the x to the 2 is first, and then the second highest, and the constant, there is no constant. So this is our quadratic, and to find, so what does it mean? It means it's a U-shape, and the leading number is negative, which means it's a U-shape that's opening down, and that means it has the max, and that's exactly what we're looking for. We're looking for the maximum area, which is known for the parabola. This point is known as vertex. So the vertex of a parabola is the x and y number, and the x is negative b over 2a. Now our a is negative 1/2, the b is 500, c is 0, but the formula does not need the c, so we don't need that. We have 500, negative 500, divided by 2 times negative 1/2. 2 times negative 1/2 is negative 1, so we have negative 500 divided by negative 1, which is 500. So the x in our garden should be 500 foot. And if the total is 1,000 and these are equal, that makes 250 for each of the vertical sides. So the dimensions, but we can also get it from this formula because it tells us what the y is. So let's check it here. If we take 500 minus 1/2 times what we think the answer is, which is 500, well, that's 500 minus 250, which is exactly 250. So the y, so the x is 500, y is 250. These are the dimensions of the garden, and the maximum area is 500 by 250, which happens to be, if we use a calculator, so here is 500 times 250. So the area that we can have, the maximum area, is here. That's 125,000. So our maximum area is 125,000 square foot. So these are the answers to this word problem. What is the maximum area of the garden? Now we can also use the calculator to find this point here, because we can make this sketch. So let's do that. Let's start with our original equation and make a sketch of it. So here is the y. Let's clear this. And the original is x times, and then in parentheses we have 500 minus half of x, close parentheses. And let's look at the picture. Now that's a window from the old equation. That's not good. Well, let's change the window back to the standard. That's a zoom 6, zoom standard. And let's see what that would have looked like in, okay, so in reality, we're not seeing much because again, our window is off. So let's use the calculator. Let's go to the zoom fit and see what window the calculator would have chosen for our picture. So here it is. Looks straight. Why does it look straight? It is not supposed to be straight. It's supposed to be quadratic. That is incorrect. So this diagram is either the window is way off or something's not right. Well, what is the window? The window should be big enough to capture on the x 500, and the height should be big enough to capture 125,000. So let's adjust the window ourselves. The x should go from, let's say, negative 100 to 600 by hundreds, so we can see what it is. And the minimum, let's say 5,000, that's fine, but that's not far enough. It should be more than 125,000, so maybe 150,000 would be enough by, let's say, 10,000. So let's see what that looks like. That looks more like a parabola. We could use a little bit more on the axis, so let's go back to window and let's add 1,000 to make it a little bit more like a U shape. So here is our maximum area curve, and this tells you the y is the area and this is the x. So let's get the maximum, calculate the max, and then we need to be to the left side of it, anywhere to the left, and then anywhere to the right. Okay, that's far enough. And then guess in the middle. So here is the answer from the calculator. The highest, the maximum is found by x being 500, and the maximum area is 125,000. Once again, this is rounding error. That is not correct. This should be not 499.999. It should be 500 even. And that's the difference, that's the advantage of being able to do this by hand and knowing what that answer should be in reality, and then verifying it with a calculator. So that's it for this example, and then just one of the classical problems for the quadratics in algebra course. Thanks a lot for your time. Take care.